So welcome everybody to this latest video on 162 Matter, and in this video we're going over recognising graph shapes by matching equations with their graphs. Now a common question in exams is stating or matching the equation to its graph or vice versa. Not only is it to recognise the general shape, either a straight line, a quadratic, a cubic or reciprocal, or even other graphs like exponentials, it is also important to recognise the x and y intercepts and basic graph transformations including reflections. So let's have a look at the general basic shapes of graphs. Now, when you're looking at an equation or a graph, it's important that you're able to work with both, because generally when you're working with these matchup questions, it does involve you matching one to the other, and it's no obvious indication of whether you're always going to be given equations or you're always going to be given graphs. It's going to be completely utterly random. Now, we have covered horizontal, vertical lines and diagonal lines in previous videos. So when you're looking at y equals mx plus c and x equals number and y equals number, so it's just kind of pulling that together. Now, if this topic isn't the strongest of yours, do not worry, because these questions usually are like 1 or 2 marks each. But obviously, if it's a multiple choice question or if it's a matchup question, then it may be a case of where it's going to be quite a few marks and each matchup will be worth 1 mark, so potentially it could be 4 marks. So let's look at the graphs in some form of order. So looking at equation, if you've got y equals a number, so what I mean by this is if your equation is just y equals 3 or y equals minus 6, so you've just got y equals a number, no x's at all, then it's going to be a horizontal line. And it will always be a horizontal line through whatever number y equals. So this, let's say if this was y equals 4, then it would be a horizontal line going through the y-axis at 4. And again, although I've not really done this, you should really also label your axes as well. But typically speaking, in an exam, this will be done for you. So let me just do that for one, but obviously don't shoot me down if I'm not doing it for the others. And likewise, if we had a negative value, then it will just be a horizontal line going through whatever value you can see. Now, one way of establishing, obviously with x equals a number, so there's no y's, that's going to be a vertical line going through. So an example of that would be x equals, let's say 2, or x equals minus 3.5. So x equals 2 would not be a horizontal line, it's going to be a vertical line. So it's going to be looking like this, going through 2. And minus 3.5 would be a vertical line going through minus 3.5. Now, one way to establish what axis it cuts through by looking at the equation is seeing what letters you can see. If you just see the letter x, then that means you're going to be drawing a line that just cuts the x-axis. If you see an equation that involves just y, that's going to be a line that only cuts the y-axis, and that's when all your values are extended. So imagine it going to minus and plus infinity. And obviously any equation that you see both an x and a y will basically be a line or a curve that intercepts both axes. So looking at y equals mx plus c, so again you may have covered this to death in regards to the equation. Let me just pull that close bracket there, and just highlight that so it's not bold. There we go. And so when we've got y equals x, mx plus c, then that's going to be a diagonal line. Now if it's positive, so a positive x will be a line that's going from left to right, it's going up. And if we have a negative x, then that's going to be a diagonal line with a negative gradient going down. So if we've got a negative x in our equation, and there, so also with regards to these equations, I forgot to mention that we also need to make them y equals. So here if I had x plus y equals 6, you might be thinking to yourself, okay, well what is that going to be? We know it's going to be a diagonal line because we've got a single x and a single y. But is it going to be, is the gradient positive or is it negative? Now with this type of equation, what we need to do is just rearrange it. So this would be y equals 6 minus x. And as you can see here, we've got a negative x. So that's going to have a negative gradient going down. So it would be a downward sort of facing diagonal line. When we move on to equations with x squared, so this is going to be a parabola. So again, a positive x squared. So again, the key thing here is when x is the highest power of x. So for example, if I had y equals x squared plus 2x minus 3, even though I've got single x, x squared is the most powerful or the highest sort of degree of x. So therefore, it will take that shape. So here I've got x squared, so it's going to be a parabola. Now, if you've got a positive x squared when y is the subject, it's going to be a u shape or a positive parabola. And let me just do a little sketch of that. And if we have a negative x squared, then it's going to be an N shape or a sad face, because obviously you feel sad when you're feeling negative. So it's always important to establish each of those, and like I said, it's all about looking at the equation and seeing what the highest degree or the highest power of x is going to be. And that moves nicely into when we've got y equals x cubed, where x cubed is the highest power of x. Now this is going to produce a cubic graph. Now one thing you do need to bear in mind is if you've got y equals just x cubed plus a number, then your graph will just basically, where x cubed is positive, then it's going to produce a shape that looks like this. If I had y equals minus x cubed minus a number, where x cubed is negative, then it's going to be reflected and it's going to look like that. Now the other thing you need to bear in mind is when we've got y equals, let me use a different colour, so if I had y equals, let's say, x cubed minus 2x plus 4, let's put a squared there, minus 4x minus 3, let's say, then what you could have is a graph where we know it's going to be sort of like a shape that looks like this, which we usually call an S shape. Now for this, because we've got a lot of other stuff, basically what that does is it kind of turns that S shape into something a little bit more S-like. So just be mindful of that. So here, if we were to plot something look like this, it would look something like that, where when you've got positive x cubed, it goes up and then goes down as we go from left to right. And likewise, if we had y equals negative x cubed plus 3x minus 7x, let's say, plus 4, then that would be the opposite direction and would look something like that. So just bear that in mind. The next type of graph we can look at is reciprocal. So this is when x is the denominator, not x is a fraction. So just make sure you know the difference. So here, this is where x is in the denominator. Now when we've got x as the denominator, it's going to produce a reciprocal graph which looks basically like this. So when x is positive, then what the graph will look like is it will look something looking like this. Now the reason why it looks like this is because the one number you can't divide by is 0. So when x is 0 at this point, it's going to give you an infinite value, like a math error. So it's going to be asymptotic, which is what we call it, which basically means that the line is never going to cross or touch that y-axis. So that's what the line looks like. And likewise, if x was negative, then it would just simply be reflected and it would look like that. And then looking at the last one, which tends to be on the higher, when x is a power, it's going to produce a exponential graph. So again, it's going to look something like this. So this is what an exponential graph is, and the reason for that is because basically the key thing is it's going to look like this, where it's always positive, and it's when x is 0, it's always going to cross through 1, because anything to the power of 0, if you know your indices, is going to equal 1. So the graph shape is going to look like that. Now obviously if we had a negative x, it would look something like this, but again it still would cross through 1. And so just something to bear in mind, and also that it's still on the positive end of your y-axis, so it's not going to go below in that sense, not unless there's a bracket and there's a negative. Now some matchup equations to and from graphs may be easy, as there may be only one type of each type of equation, but sometimes there may be similar looking equations and graphs with only subtle differences. They could be reflected or shifted vertically or horizontally, and this is where the topic overlaps with graph transformations, which I'll try and put in another video. Now, a more detailed analysis of an equation and its graph will need deeper study into the type of graph. So for example, if you're looking at quadratics and you're asked to sketch a quadratic, it may be a case where you not only have to state the y-intercept, you also need to state the x-intercepts and the max and minimum point, which again then involves completing the square. The same thing with regards to cubic graphs. If you're asked to plot those accurately, which again is very common on the higher GCSE, again you can't just simply get away with just doing a little sketch. It needs to be done accurately. But again, This particular video is only looking at when you are asked to match an equation with a graph that's already been plotted rather than one that you actually need to do. And also just make sure that you do look out for that word sketch. Sketch means you can do what we're doing in this video. Plot means that you would need to do it accurately by drawing a table of values. Now, a simple and quick way to establish which type graph belongs to which equation is to find the y-intercept by substituting x equals 0 and look out for any negatives. Now, with this, we kind of touched upon with negative x's in the previous bit of the video, where you can see what happens. In most cases, again linking with graph transformations, it will simply be reflected on the y-axis, but on rare occasions it may be reflected on the x-axis. And again, more detailed explanation about which is when is going to be covered in graph transformations. So now let's have a look at some example questions. Now you can download this sheet by clicking on the link in the description if you want to have a go at it, or you're wanting a copy for your notes. But let's have a look at this. Now, obviously in an exam you're not going to get an extensive set of matchup cards. You probably only get 3 or maybe 4. It may even be multiple choice where you just get 4 graphs and you just got to match up which equation, or vice versa. So let's have a look at question 1. Now with these, what you want to do is establish which graphs are what type. So for example, if I just kind of color code these, so let's have a look at the types of graph we can have. So this is going to be a straight line. And that's going to be, now, as you can see, looking at the equations, we've got no x equals a number or y equals a number. So it's going to be a diagonal line. Or if I can spell it, which clearly I cannot. So it's going to be a diagonal. So looking at this, what we're looking for is equations and lines with just a single x and a symbol y. So here D is a diagonal line, F is a diagonal line, and L is a diagonal line. So if I just match up those equations, I'm looking for an equation with just a single x and a single y with no powers involved at all. So here this is going to be either question 1. Going down the list, I've got question 10 and 4. Then moving on to the next one, so let's just highlight this in green. So here we're looking at parabolas, in other words quadratic graphs, where the highest power of x is their square. So looking at the shape, we're looking for U shapes and N shapes. So I've got A, B, I've got I, and I've got G, and I've also got K. So I've got quite a lot of quadratic graphs there. So what we're looking for is x squared. So things where the highest power of x is 2. So it's going to be 5, it's going to be 9, because if I expand those brackets out, I'm going to get something x squared. Question 11, question 14, question 12, question 8, and I think that's it. The other type of graph that we can see is we've got a cubic graph. In other words, an S shape. So let's just highlight those. So here we've got J and C. So looking for highest powers of x is a cube, so it's 3. So looking at 1, 2 and 3 and 13. And then we're looking at the ones that we've got left. Oh, we've got a H there. We've got to highlight that one. And so the only graph we've not really established is E, and that is an exponential graph. So let me just color code that one. Which is this one here, and that's there. And again, I knew I'd missed one out. There's our last diagonal. So what I've established here, and as you can see, apart from the exponential graph, as I've only got one of those, I've only got one equation that refers to that. So it's pretty fair to say that if I start writing my answers, that matching these up, E is definitely going to be 6. So E equals 6. And what I'm going to do is I'm just going to tick that off so that I'm not going to be concerned about it. Actually, let me just colour it in so that I can see which ones I've already used. Now looking at the rest, as you can see, I've got multiple choices of similar types of graphs, but it's a case of which one refers to which. And this is where we kind of need to look into more detail about how the equation is structured. And this usually implies by the number being added or subtracted, but also the sign of x. So looking at A, we can see that this, with A, it's intercepts the y-axis at 0. So what I'm looking for is just x squared, no numbers attached to it. So here, looking at this, I'm looking at just y equals x squared, and that is 12. So a is going to equal 12. So again, I can just kind of get rid of that one. And there we are. So looking at b, so this is going to be a positive x squared. So again, a positive x squared, where I'm adding, now the y-intercept is +1, or it's going to be a positive number. So the y-intercept is positive. So I'm adding a positive number to y squared. So I'm looking for something with x squared where I'm adding a number. Now looking at this, well, where I'm shifting it up, so I'm looking for x squared +1 or something along those lines, and I cannot see it there. So again, there is one where I need to draw it, so I'm just going to leave that one there. I think out of the blue choices, the green choices rather, here it is. We're looking at 5, so that's going to be B5. They're looking at C. Let me just colour that one in, say that we've done that one, and 5 is there. Now for the next one, for C, we're looking for a negative x cubed. So I'm looking for negative x cubed, and as I can see straight away, that's going to be 5. So here C equals 5. And also I know that there's nothing being added because it crosses the origin. So when a line crosses the origin, you're not going to be adding or subtracting anything. If it's below the x-axis, you're going to be taking away a negative constant, and if you're adding something like a positive constant, then you're basically shifting the graph up. So C equals 5, so I can colour that one in, and colour the this one here. So we've got, sorry, that's going to be C equals 3. I don't know why I've put 5 there. What colour are we using? C equals 3. Then moving on to our next graph, D. So here what we're looking for in D, I'm looking for a single x, and I'm looking for a negative x, and as you can see the y-intercept is negative, so I'm taking away a number, so a minus number. So again, I'm looking for negative x and taking away a number with single x, single y. So looking at the equations, I'm guessing it's going to be number 10. So D equals 10. So again, let's just cross them off. Then moving on to F. So here again with F, I'm looking for a single x, single y. I'm looking for negative x, and I'm looking for a positive number. So I'm looking for negative x with a positive number, and that seems to me as being 7. So that's going to be F equals 7. So again, I can colour that one in, and 7 as well. Then for the next one with G, so this one here, I'm looking for a x squared, a positive x squared, because it's a U shape. But here I'm shifting it along, let's say, to here. Okay, so I'm shifting it along 1. So that's going to be where you're taking away 1 or taking away something. So you're subtracting from x. Now this really does apply to graph transformations, but basically speaking, the equation is going to be question 9. So it's going to be G9. And again, I can cross that one off. Then moving on to H. So for this one, again, I'm looking for positive x, single y, because it's diagonal. And I'm looking for plus a number. So looking for positive x, positive number being added. So I'm going to go on a whim and say it's number 4. So here H equals 4. Then moving on to I. So this looks like an N shape. So here I'm looking, and it's a parabola. So I'm looking for a negative x squared with no number being added. So no number at the end. And that to me is going to be number 11. So I equals 11. And I can see I forgot to circle those ones. I don't think I have 9's been used. So running out of graphs slowly. With J, again, here we're looking at an S shape that crosses through, so I'm looking for a positive x cubed with no number being added or subtracted, and that's going to be 2. So J equals 2. Then for the next one, for K, I'm looking for a positive x squared, but this time I'm taking away a number or shifting it down 1. So taking away a number, and that is going to be 8. So K equals 8. So let's just highlight that one, and 8. And looking at L, so again that's going to be a diagonal line, and there's only one blue one left, so L is going to equal 1. And again, how do I know that? It's because I'm going to end up with a positive x and subtracting a number. So L is going to equal 1. So again, I can highlight that one. So the next thing for me to do is to basically plot these two graphs here. Now with 13 is going to be a sort of shape that looks like this, but I'm going to be taking away 1, which basically means I'm going to shift that graph down 1. So this I'm going to draw on N here. So it's basically, if that's where it crosses the origin, I'm going to shift it down 1. Now it doesn't really matter because I'm not really labeling the points, or I can do, but that's basically going to be there. So here N equals 13. Then the next thing, the last one for me to then draw is x plus 1 squared. So this is going to be a U shape, but it's going to be shifted 1 space to the left. So if it crosses the origin there, I'm going to shift it somewhere on the left, and so it looks something that looks like that, and that then is going to be M equals 14. And there we go.